Good morning, students. So in this video, I will be teaching you diazonium salts. Diazonium salts. So this is from your chapter amines. It's a very important compound, diazonium compounds. They are represented by Ar N2 plus X minus. They are represented by Ar N2 plus X minus. The aliphatic diazonium salts are unstable. The aliphatic diazonium salts are unstable. Here X means it can be like chloride ion, it can be bromide ion, it can be hydrogen sulfate ion. And this N2 plus group is called the diazonium group. The N2 plus group is called diazonium group. Like if you draw a benzene ring with a diazonium group plus Cl minus, then it is called benzene diazonium chloride. If you write benzene with a diazonium group and HSO4 minus, then it is called benzene diazonium hydrogen sulfate. Hydrogen sulfate. If you write a benzene and then write a diazonium group plus BF4 minus, then it is called benzene diazonium fluoroborate. Benzene diazonium fluoroborate. So aliphatic are unstable. Aliphatic diazonium chlorides are unstable. Aliphatic diazonium compounds are unstable. But aromatic are stable, and that is due to resonance. So keep this in mind, student, that the aliphatic diazonium compounds are unstable. Because there is no resonance in aliphatic. Aromatic diazonium compounds are stable, and their stability is due to resonance. The alkyl diazonium immediately form a alkyl carbocation with the release of nitrogen gas. Alkyl carbocation. And you have to keep that the Arene diazonium compounds or the aromatic diazonium chlorides compounds are stable, and that is also in solution for a short time. That you have to keep in mind. Now let's see how we will prepare aromatic diazonium compound. So preparation of Arene diazonium chloride. So you have to take aniline. Treated with sodium nitrite plus HCl at 273 to 278 Kelvin. It forms benzene diazonium chloride. Plus sodium chloride plus water. The process is called diazotization. So the formation of diazonium chloride from aniline using sodium nitrite and HCl is called diazotization. So this has been asked in CBS in +2 also, and it is asked in entrance exam also. So keep this in mind. Now, why we take NaNO2 HCl? Because what happens if you treat directly with HNO2, HNO2 being an unstable compound. So this HNO2 is a nitrous acid is prepared by the treatment of NaNO2 HCl. So HNO3 is synthesized in situ within the reaction. Now, properties of diazonium salts. Properties of diazonium salts. Benzene, diazonium chloride is colorless crystalline solid. It is a colorless crystalline solid. So since it is a salt, it is highly soluble in water. So it is readily soluble in water. But it is stable in solution at low temperature. In boiling water, it can form phenol. In boiling water, benzene diazonium chloride forms phenol. Benzene diazonium fluoride, it is insoluble in water and it is stable at room temperature. It is stable at room temperature. Now we will see chemical properties. Chemical properties of diazonium salts. So first we will start with Sandmeyer reaction. Very important reaction for your exam, entrance exam like IIT, NEET, MSET, BITSET, as well as for board exam. So if you treat benzene diazonium chloride with Cu2Cl2 in presence of HCl, then chlorobenzene is formed. Plus nitrogen gas is released. If you treat it with CO2Br2, HBr, then bromobenzene is formed. Plus nitrogen gas. If you treat CuCN in presence of KCN, then benzonitrile is formed. Benzonitrile is formed along with release of nitrogen gas. This reaction is called Sandmeyer reaction. This reaction is called Sandmeyer reaction. So the chloride, bromide, and the cyanide nucleophile can attack the benzene ring in presence of copper 1. This reaction is called Sandmeyer reaction. Now, it is one of the important reactions for your exam. Keep this in mind, students. Next reaction is when benzene diazonium chloride is heated with Ki, it forms idobenzene. It forms idobenzene plus nitrogen plus KCl. So this is a very good method for the preparation of idobenzene.